Now I'm going to go over the ear, and this is a larger model, so it's kind of hard for me to get it in view for you, but this is an anterior view of the ear, and now I'm going to turn it so that you can see all parts of this model. So we will start with the outer ear. The outer ear, this structure here that you can see and feel on your own body and pierce if you choose to, is called the pinna. Some books also call it the auricle, but your book calls it the pinna. Also in the outer ear is this tube. This is where you might put a Q-tip, right? This is called the external auditory canal, because auditory means hearing, and it's external, and it's a canal, right? And then all of this that looks like bone, see spongy bone and it's white, that is bone. That's the temporal bone. You learned that the external auditory canal passes through the hole in the temporal bone, and the hole allows sound waves to come in. Okay, that's the outer ear. The boundary between the outer ear and the middle ear, I'm going to point to the middle ear. The middle ear is actually an air-filled cavity. I'll get to that in a minute. But the boundary between the outer ear and the middle ear is the tympanic membrane right here. So this is the tympanic membrane, which is also known as your eardrum. But we don't call it that anymore. We're going to call it the tympanic membrane. It comes out, so when I remove it, you can see this air-filled cavity. So this is an air-filled cavity, right? And then this is an air-filled cavity. And all cavities that are open to the environment are lined with mucous membrane. But if the eardrum, the tympanic membrane, completely closes off the middle ear cavity from the external auditory canal, then how is there air in there? The reason that there is able to be air in there is this tube right here. This is called the auditory tube. Some people used to call it the eustachian tube. It's been many years since people used that term. So the auditory tube leads to the throat. So if you open your mouth real wide and you take a breath in, you're allowing air to pass into your auditory tube and into the middle ear cavity. The reason why you have this tube is to equalize air pressure on each side of the tympanic membrane. The tympanic membrane is really, really thin, and it's quite fragile, actually. It ruptures. I've ruptured mine 23 times, so I have extraordinary insight into this. Once you rupture it once, it becomes very weak, and it ruptures more easily from then on. But if you don't have equal pressure on each side, then it could rupture, like it did for me. And what happened with me is that I had a cold and a whole bunch of, it was an ear infection, middle ear infection. So there's a bunch of pus and fluid in the middle ear, and it just ruptured through the tympanic membrane and then came out my external auditory canal. But my point is that when you change in altitude, when you go up in an airplane, for example, or come down a very large hill, that change in pressure can mean that there's more pressure on the outside of the body than there is in the middle ear cavity, or there's more pressure in the middle ear cavity than there is on the outside of the body. And if there's more pressure in here, then the tympanic membrane is not going to be the shape it's supposed to be. So let's see if I can show you that it's shaped like a bowl, and more specifically like a cone. So this edge around here is bone, but you can kind of see that it's shaped curved. It's like a bowl, and if there's more pressure in the middle ear, it's going to push the tympanic membrane so that it's flat, not bowl-shaped. In fact, it might even protrude in this direction, and a doctor can, and a nurse can look at your ear from the outside with an otoscope and see that actually happening. But then you can't hear, is my point. If the pressure is different on each side of the tympanic membrane, then you cannot hear, because the purpose of the tympanic membrane is to vibrate. So the sound waves come in the external auditory canal and hit the tympanic membrane, And then the tympanic membrane vibrates and pushes on the 3 bones that are found in the middle ear cavity. So now I'm going to show you 2 of those bones. One, first of all, this thing here is just made so I can hold it. It's not a real anatomical structure. It's actually a piece of wire, rubber-coated wire. And then this bone is attached to the tympanic membrane. So the first bone, if you're moving from outside the ear inward, the first bone is called the malleus. So right now I'm touching the malleus. The second bone is attached to the malleus. It's called the incus. The third bone isn't attached to the tympanic membrane. So I'm going to put this back, and I'm pulling out now the inner ear. Trying to get the dark background so you could see better. So this is the inner ear. I'm going to move it all around so you can see it. And here is a bone that kind of looks like the stirrup on a horse saddle. That's called the stapes. The stapes then presses on the inner ear. The rest of this is the inner ear. The rest of the white part is the inner ear. So the inner ear has 2 main parts. The part that I'm holding in my hand right now is called the vestibular apparatus, and it has 2 parts itself, but the function of this part that my hand is covering right now is equilibrium. And then you have this coiled up snail part of the inner ear, and that's the cochlea. That handles hearing. So our inner ear has 2 functions, hearing and equilibrium. And the cochlea is hearing, and the rest of this is equilibrium. And remember, this is a bone. This is not a part of the inner ear. This is actually in the middle ear, but they put it here because I guess it was breaking off too much if it was attached to the other bones, so they changed the design of the model. Coming out of the back of the inner ear are 2 nerves, and they're yellow. Now, this enlarged area here is called the vestibule. It handles equilibrium. And then these 3 loops are called semicircular canals, and they also handle equilibrium. So both of these handle equilibrium. You'll learn in the lecture part of the class what different kinds of equilibrium. One is static, meaning equilibrium while you're not moving, like right now I'm sitting, and I don't fall out of my chair because of the vestibule. It keeps me upright. And then the equilibrium of motion, like riding in an elevator or driving a car, would be the semicircular canals. So coming out of the back of the cochlea is a nerve, and then this nerve has been cut, this one, but it was attached to the vestibule. So these 2 nerves combine to form one of the cranial nerves called the vestibulocochlear nerve. So that's what this is, the yellow nerve. Vestibulo means vestibule, cochlear means cochlea, and so this cranial nerve number 8, handles both equilibrium and hearing.